Hello and welcome to the training video for GIS tools for assessing bicycle suitability. My name is Mike Lowry. I am a professor of civil engineering at the University of Idaho, and I will take us through this 50-minute training video. The video has three parts. I'll begin with some background about bicycle suitability, and then I'll explain how to use the new tools with example data that's provided with the tools. And then I'll conclude explaining how to enter your community's data to use the tools. This project was motivated by the customer satisfaction survey conducted by ITD each year. Consistently, the survey results show that Idahoans feel bicycling is important. For this reason, ITD sponsored this project with the goal of creating GIS tools to assess the comfort and safety of bicycle travel. The scope of the project is focused on engineers and planners to help them prioritize improvement projects. The tools are not intended for public use. They might be used in a public outreach way, but the intention is to provide tools for engineers and planners that have GIS skills. The output of the project is the final report, which can be obtained from ITD, and the tools themselves with help files and example data. I won't take too much time to discuss the report, but I do want to point out some things that are found in the report. Chapter 2 covers the literature review, discusses bicycle suitability, bikeability, and bicycle friendliness, reviewing the literature over the last 2 decades dealing with these assessments. Chapter 3 discusses the results from a survey that we conducted. We sent an electronic survey to communities across Idaho to find out about data availability and GIS capabilities. Chapters 4 and 5 go over and explain the tools. Chapter 5 uses some example data, which I'll be using today in this video. Let me begin with some of those definitions. Bicycle suitability is the perceived comfort and safety of a linear section of bikeway. Bikeability, on the other hand, is somewhat different. It's the perceived comfort, safety, and convenience of an entire bikeway network. In other words, it's a community-wide assessment compared to the assessment which is just of one small, perhaps short section of bikeway. Bicycle friendliness is an assessment of all aspects of bicycle travel, particularly assessing the general acceptance of bicycling in the community. Now, these three levels of assessment have a similar and parallel assessment with walking. You could say that a roadway is suitable for walking, that a neighborhood or community is walkable, meaning that it has perceived comfort and safety is good for accessing important destinations, and you could say that a community is pedestrian friendly. And these three levels we're now looking at with bicycle suitability, bikeability, and bicycle friendliness. The focus of our tools deal with bicycle suitability. There are a lot of methods for assessing bicycle suitability. This table shows a list of many of the methods that have been used in the past, from the first method developed by Davis in 1987, the Bicycle Safety Index rating, all the way to the most recent bicycle level of service, which is found in the Highway Capacity Manual. Now, all of these methods essentially do the same thing. They take attributes of a roadway, such as the width of the bike lane, the width of the shoulder, the speed limit on the roadway, and they use this information to determine a score or rating of the bikeway. Here's one example. This is the bicycle suitability score. This method uses 4 attributes of the roadway: the traffic volume, shoulder width, speed limit, and pavement. The user, the person assessing the roadway, goes to an input table, looks up the information for each of these attributes, goes across, finds the factor score, first for volume, then for shoulder width, puts this into the equation, and calculates the suitability score. The output number then is used to define and assess the quality of bicycle travel for that roadway. There's a lot happening on this figure, and I won't go over it anymore, but I refer you, if you're interested, to look at the report. This method, along with many others, are found in the report and described in the report. Let me show you one other method. This is the bicycle suitability assessment. This method is interesting because it was intended for public use, for the public to go out, citizens to go out and assess attributes of the roadway, and then take that information
and put it into an equation that can be then used to calculate a score. Again, this score is a rating of the perceived comfort and safety of this section of roadway. This is the equation for the bicycle level of service method. It uses 10 attributes: the width of the outside lane, the width of bike lane, etc. And this information is put into the equation to calculate a bicycle level of service score. This method was developed and is found in the Highway Capacity Manual, the most recent version of the Highway Capacity Manual. The score that it produces is then used to find a level of service grade, letter grade. So the result might be a bicycle level service B or D, depending on these input attributes. All of the bicycle suitability methods require input attributes. Here I have 5 different methods and showing which attributes are needed. Across the top here, this is bicycle stress level, which only requires 3 attributes. The bicycle suitability score, the bicycle compatibility index, the bicycle suitability assessment, and then the Highway Capacity Manual's bicycle level service, which uses 10 attributes. These assessment methods are primarily intended for engineers and planners to prioritize improvement projects. They can also be used for the public in this way. This is a map for a community that took bicycle suitability scores and color-coded it onto their road map for the public use. And then they define each suitability level, excellent, good, and so on, for the public. The tools that I will be explaining could be used in this manner, although their primary intent and purpose was for engineers and planners when prioritizing projects.
Hello, welcome to the training video for GIS tools for assessing bicycle suitability. My name is Mike Lowry. I'm a professor of civil engineering at the University of Idaho, and I will take us through this 50-minute training video. The training video has 4 parts. I'll begin with some background information about bicycle suitability, and then I'll provide an overview of the new tools, and then I'll demonstrate the tools with some example data, and finally I'll conclude by explaining how you might be able to enter your own data for your community. Now I'm going to discuss and demonstrate the new GIS tools. The tools were created for ArcGIS 10 and do not require any special licensing, so the basic license for ArcGIS 10 is sufficient to run the tools. There are 14 tools. The tools are organized in a toolbox called the Bicycle Analysis Toolbox. In the first tool set, there are 5 data preparation tools. The second tool set has the suitability tools, and these are the primary tools used for the analysis. In a moment, I'll go to ArcGIS and I'll demonstrate each of these tools. But first, let me show the interface for one of the tools. This is the interface for Calculate Bicycle Level Service for streets. The user of the tool provides an input file, and then the attributes associated with that input file, and the user also defines the output of the tool. In this case, the output is a new field called Bicycle Level of Service Score, and a second new field, Bicycle Level of Service Text, which will be the letter grade. The other tools have similar interface. Let me go to ArcGIS now and show you how these tools are used. The tool can be ran from a USB drive or from the CD or any data storage device, but it's recommended to move the tools to your to your hard drive because they'll run a little bit faster. Once you have copied them over, connect to the folder where they're at, the ITD Bicycle Analysis Tools folder, and in that folder there are the Bicycle Excel tools, which were also created for this project. Let me expand the folder that has the GIS tools. First thing you'll see is that there's a folder for example data. This is the example data that I'm going to use in this tutorial. There's also a folder for tool data, which actually has the computer code for the tools and is not necessary to open unless you plan to edit or change the tools. Then the toolbox has the tool sets, so there's the data preparation tools and the suitability tools. Right now I'm going to focus on the suitability tools. I'll go through each one individually. Let's start with Calculate Bicycle Level Service for Streets. I'll pull in from the example data the street shape file. This is the street shapefile for the city of Moscow, and if I open the attribute table, you'll see that for each street in Moscow we have attributes and the data associated with those attributes. These attributes are showing the number of lanes, the speed, the percent heavy vehicle, and so on. Now, the letters that I've used for these fields are the default names for the fields in the tool, but any name could be used. Instead of V for volume, you could write the word volume, or you could write the word lanes instead of N, or write the word speed. It doesn't matter what you call these attributes, you're able to identify them when you're using the tool. Let me show you how that works now. So I click on the tool and I open it up. And so you'll notice again, this is the interface. This time it's showing the help. You can hide the help or show the help by clicking on that button. And this is the overall what the tool is going to be doing. And then when you click in each field here, the help changes and it provides information for that particular piece of input or output. So going back to the first piece of input, it wants the shapefile, the street shapefile, which I, for simplicity, am calling streets for this tutorial in the example data. And then it wants to know the attributes associated, the 10 attributes for calculating bicycle level of service. Well, again, I've already named them the default values which it was looking for, WOS, but I could have named them anything, and then this is where I tell the tool to find that field. Since everything has the default value, I'll keep it that way. And then the output field, I'll also leave it as the default BLOS score. But again, I could call this BLOS score 1, which would maybe be for scenario 1. And then I could go in and change the width of the bike lane, for example, and then call it BLOS score 2 and have a different score output for a different bikeway system, for a different street system under different conditions. Now that I have all of the input there and all of the output defined, I'll click OK and run the tool. It's running the tool with these notes, and you see it took just 3 seconds to run that tool. Here's the output. It has color-coded all of the streets. And if we look in the legend up here on the left, it shows that from A to F, that's what these colors represent. And there are mostly level of service A's in the city of Moscow, but a few level of service F's even. These are the highways in town. And I'm going to close that down. And now I'm going to go to the output to see what it did. And it created 2 new fields, the bicycle level service score and then the bicycle level service text, which is the letter grade. And it calculated those based on this input. Now I'll show you the tool calculate bicycle level service for intersections. So let me bring in the intersection file for the city of Moscow. And there, let me turn off streets so that we can see that better. Those are all of the intersections for all of the streets in Moscow. Again, if we open the attribute table, it has the attributes for each intersection. Let me click on the tool. The first attribute that it wants to know about is signal. And again, open that up. You'll see that most of the attributes actually are zeros, except for when there's this field where it says signal. And this is the field that has information. The Highway Capacity Manual, the current edition, actually only provides a calculation for signalized intersections. So the data is empty for everything else because it's irrelevant for this tool at this time. Perhaps future editions of the Highway Capacity Manual will provide a calculation for unsignalized intersections. So I'm going to tell it where the input shapefile is, intersections. And again, it's looking for that field signal and then all of the other attributes, and it will provide the calculation. Since I have the default, I don't need to change any of this. And I'm going to go ahead and keep the default output fields as well. Click OK. It runs fairly quickly, 2 seconds. And there you have it. Here are the bicycle level service for the 16 signalized intersections in the city of Moscow. Again, most of them are bicycle level service A. There's a few, looks like B and C, but that's as low as it gets for the signalized intersections in Moscow. Now when we open up the attribute table, we actually did assign a level of service to all of the unsignalized intersections. We gave it a level of service A. And that's something that the Highway Capacity Manual suggests to do until a further method is developed for unsignalized intersections. So then the next tool is calculate bicycle level service for a facility. Now, I open up the tool, and there's a few warnings that are happening here. And the first set of warnings, which are also explained in the note in the help file, is it saying that you have to identify and highlight the starting intersection and the ending intersection for a facility. Now, a facility could be what the Highway Capacity Manual defines as a facility is a contiguous set of streets and intersections. So we could choose any group of streets and intersections, and that will be what we would call facility. Let's choose this stretch right here. And the first thing we need to do, as is noted there, is to highlight. So we go up here and we go select feature. We're going to select this intersection. We'll start there and we'll go to this intersection and we'll call that our facility. To help me select it and make sure I only get one intersection, I'm going to zoom in and then select that intersection. Now it selected the links, the streets as well, but that's okay. Just as long as I get one intersection and only one intersection. And we'll go to here. So I'll zoom into that. And then now I have to hold Shift. So I'm going to hit, get that button going, and then I hit Shift here. And now I have that intersection as well. Go back to my previous view. And you see here's our start intersection and our closing intersection. Now the other thing that's happening here with this information in the help file is this method. There are 3 different methods for calculating bicycle level service for facility. The standard method, the modified method, and then a custom method. Let's go ahead and do the standard method. There's more explanation of these 3 methods in the Highway Capacity Manual, as well as in the report that was created for this project. We'll go ahead with the standard method, and then we will provide the input street file, and it's wanting to know where's the BLOS score. It's necessary to run the streets bicycle level of service before running the facility level of service because it will read from that new field called bicycle level of service score. And then it needs the intersection file, and I'll put that there. And then this warning here is telling us that we need to say where the output is, and if we hover over that, it tells us that the output cannot be a geodatabase. The output location must be a folder. So I'm going to click on that, and I've already created a folder. I'm calling it temp, and this is where I'll put my output. So I'll put this as facility output. And then the next thing it asks for is, and this is just a warning, but it's wanting to know the name of the file. If I don't provide anything, then it'll put that name that's there. But let's go ahead and put in Pullman Highway. So now that'll be the name of the facility that is associated with this new shapefile that's created. I'll click OK. It's running the tool. This tool takes slightly longer than the other tools. It's having to do more calculations. And again, any facility could be created along any set of intersections and streets, and then you could append all of the intersections and streets together, the facilities together, to make one big facility file. Here this created the output. It took 19 seconds. I'll close that. Let me turn off the streets so it's a little bit easier to see. This was the facility right there, and when I open the attribute table, you'll see it has this new one feature, which is the Pullman Highway, and it has a BLOS score of D. So that's bicycle level of service for facilities. Now let me show you bicycle level of service for pathways. I'll pull in the pathway file for the city of Moscow. These are all of the pathways. We can turn the streets back on to see how they're connected. These are the pathways throughout the shared use paths, and there's little pieces here and there that are connected. And again, I will run this tool. Likewise, there are various methods for running the bicycle level of service for pathways. There's the standard method and the modified method. we'll go ahead and do the standard highway capacity manual method. And the details for this method are in the highway capacity manual as well as in the report that was created for this project. It wants to know where is the input shapefile, so we'll provide the shared use pathways. I've called it shared use pathways on the example folder. We'll go ahead and keep the default names for all of these things. It's wanting to know the width and if there's a center line painted or not, and a few other things that can be gathered through surveys. And once this data, again, the highway capacity manual explains this data and this input and how one might obtain that data and input. The output we'll go with is the default BLOS score and BLOS text. We could rename this scenario 1 or something if we'd like to. We'll hit OK and run the tool. And there it ran, and it's showing. Let me turn off that facility. We'll close that. Turn off the facility and the intersections, and to see the bicycle level of service for the pathways. And it looks like we mostly have level of service B with one stretch of level of service C, which happens to be going through the university campus right there. So because of the crowds of students, it had a lower level of service. So those are the 4 bicycle level of service calculations, and all of those are based on the highway capacity manual. The details can be found in that manual. These next 2 methods are 2 other suitability analysis methods. The first one is the bicycle stress level method. So let's turn the streets back on, and we see right now it's showing bicycle level of service, but when I run this tool, it'll change it to the bicycle stress level output. So again, it's asking for the bicycle stress level input file will be the streets. It's going to take these 3 attributes, and it will put a BSL score in a BSL text. That's for bicycle stress level. So when I click on OK, it runs the tool. Took 2 seconds. Changed the colors because it is now associating the new output field with these values. This is the output for bicycle stress level. So high stress, low stress, moderate stress, and very low stress. And you can see that again, it's these highways that are showing the high stress levels according to that method. So then the next tool is the, well, and let me just open up the attribute table. You'll see, for the streets, the attribute table. So we now have not only the BLOS score and BLOS text, but BSL score and BSL text. So now I run the Calculate BSS tool, and this tool was developed by Turner for the Texas Department of Transportation, and it also wants to know the input of the streets, but it only takes 1, 2, 3, 4, 5 input attributes, and then it'll have the output of BSS score and BSS text. And when I run this, it runs, and there you have it. This one changed the color because it's now associating the streets file with these output possibilities, and under this method it looks like most of the streets are most likely desirable and a few are could be desirable. This method goes with these 4 categories. It may not be desirable and undesirable, but there are none of that level in the city of Moscow for this example data. So there are the other 2, Calculate BSL and Calculate BSS suitability methods. Now I'm going to go through the Calculate Community-Wide Bikeability tool. Let's just to get us back to BLOS, because these tools, the next 2 tools were actually created for the BLOS. I'm going to run that again, and this time you're seeing the note that came up said that field already exists, that field already exists, and then it's overwriting those fields, and I'm going to close that. But that's okay that it overwrote it because that's the values we wanted. Here's the output. Now, what the Calculate Community-Wide Bikeability is going to be doing, it's going to say, okay, well, here's the bicycle level service for all of the streets in the city, but what if I want to go to the various destinations? is it bikeable to get to those? That's what the term bikeability is referring to. So let me bring in some destinations. I could choose any destinations, but for example data, I have the grocery stores in the city of Moscow. So here I brought them in, but I'm going to change their symbology to make it a little bit easier to see. Let's take this up to 12, and we'll go with this color green here. Go ahead and apply that. So there they are. There are actually only 4 grocery stores in Moscow, and this 5th grocery store is one that's proposed. It's not there right now. These 4 are existing, but this one in the northeast is not there. And we want to know, is it bikeable to get to these grocery stores? If we lived in a residential area, say in this neighborhood or any neighborhood, how bikeable is it to these grocery stores? So the next thing we need to do is bring in some analysis zones. And this could be a parcel file, or it could be just some zones that were created. And so that's what I have here. These are zones. Let me turn off a few things so that we can look at that. These are the zones that we're going to do the analysis for to calculate bikeability. But it could be a parcel file, which I'll show you, for example, in a moment how that would work. But let's say we have these zones, which happen to have been created, by the way, with this data preparation tool, create analysis zones, and I'll show that as well. So now that we have this, we're going to run the tool, calculate community bikeability. And here it explains how the tool works and what the output's going to be. And the first thing it wants to know is the bikeway network. The bikeway network actually is streets and shared use paths. We just have streets right here, but we could append streets and the shared use paths together to make it one file. In fact, I did do that. Let's just go ahead to here we have bikeways. So this file, which I just brought in, it's from the example data, is the streets file and the pathway file appended together. And append tool is an existing tool in ArcGIS, which you can use very easily to combine two polyline files. So yeah, let's use those ones. I'm just going to go ahead and remove the streets and instead use bikeways. We'll open up Calculate Community-Wide Bikeability, and we'll go to that bikeways, streets and pathways. And now it wants to know where's our analysis zone. We're going to go to these analysis zones, and I call them big analysis zones because they are rather big. They're 900 feet by 900 feet. But when you do the create analysis zones in the data preparation, you can choose smaller zones if you please. And then it wants to know where are the destinations. And again, the destinations are those grocery stores. Let me go back and open up that attribute table. So here are the grocery stores. There are Winco, Safeway, Co-op, and Rosars. Those are existing. And then there's this 4th grocery store, which is proposed, and it's not existing. Well, what we're going to need to do is associate points with each destination. So we'll give equal points to all the grocery stores, but we could give more points to a particular grocery store if we wanted. We'll give equal points to all of them, and we won't give any points to the one that's not existing in the current condition. And in the proposed condition, we'll give equal points to all of them, including the new proposed grocery store. So you see here, it's asking for that file. This is the destinations file. And then it's asking for the destination points. And so that's meaning the point value associated with it. So we're going to go ahead and put in the word current and refer it to that field current where the points we're going to be going for existing grocery stores. And it's wanting the output. Again, it's saying where are you going to put this? It needs to be in a folder. So I'll click on this and we'll go to this temp folder which I created, and we'll call this Bikeability, and we'll make it scenario 1. And we'll click on that. We'll hit OK, and the tool starts to run. Now this tool actually takes a little while. On my computer it takes about 4 minutes, but I have a pretty fast computer. On slower computers it might take up to 15 minutes. So as this runs, I'm going to fast forward the video. Okay, this tool is just about finished running. It's finalizing the output now, and in a moment it will provide the output there. It's completed, and on my computer it took 4.5 minutes. On other computers it might take up to 15 minutes. So let's look at the output. Let me close this. What it's doing is it's shading with a darker color the zones that have better bikeability. and it's scaled from 0 to 100. So here in this area, not surprisingly, the bikeability is quite high because it's close and easier access to the 4 existing grocery stores, the best bikeability being about in the middle. Now further on the edges of town, bikeability is worse because it's a longer distance to get to any of the 4 grocery stores. So now let's turn that off and run it again. We'll turn on the bikeways and the analysis zones. We'll run it again. This time, so it wants to know where the bikeways are, where are the analysis zones, where is the destination shapefile, grocery stores, what is the destination points field. This time we'll do proposed. So this is then giving 1 point to the new grocery store as well. And we'll call this one Bikeability 2. So scenario 2. We'll hit OK and we'll run. Again, while this tool runs, I'll fast forward the video. Okay, this tool is almost done. It's just finalizing the output, and it will provide the new, there it is. Again, it took 4.5 minutes. Let's look at this output now. There's a change that's happened. Now we have higher bikeability up in this northeast area because there's a new grocery store. So the land use changed, and because of that, bikeability for the residents in the zones in this area has improved. They have better bikeability because they have access to a new grocery store which is up in this area. Now it's often easier to compare scenarios side by side, so let me go back to PowerPoint. What we see here is the same output that I've clipped and put into PowerPoint. So this is scenario 1. This is showing the bikeability when we only gave points to the existing destination grocery stores. And now, when I click on this image, this second image, this is scenario 2 with the new grocery store. And you can see then there was an improvement in bikeability in the northeast area. Now, the great thing about this tool is right here we're seeing an improvement in bikeability due to a land use change. So that's the first way bikeability can be improved. The second thing that the tool is analyzing and determining bikeability score is the infrastructure to get to the destinations. So if we were to add new bike lanes connecting these destinations or connecting out to some different analysis zone on the edge of town, then the bikeability would also be improved along that new infrastructure. To illustrate that, let me go to this figure. This is a figure taken from a publication that we submitted and will be published in 2012 for the Transportation Research Board. In this publication, we used a fictitious 2-centered community, and the blue dots represent the destinations, and the lines actually are perfect grid of streets, and we gave level service, bicycle level service of a C or D to all of these streets with the perfect grid. Now, depending on whether it was a C or D, you see that the bikeability score is shown in the colors, and there's obviously higher bikeability when you're right close to all of the destinations. But the in-between and on the outskirts, it has poor bikeability. Now that's scenario 1. When we click on this, this is scenario 2. And this one we're highlighting that there was a new bike path put in with bicycle level service A, the entire length of the path. The new bike path, because of this improved infrastructure, the bikeability all along the path has improved because anyone that would live out here on this path has a more comfortable and safe and more convenient way to get to the destinations. And so the Bikeability tool has this ability to show bikeability in terms of land use changes and as well as infrastructure changes. Let me go back to GIS to highlight a few more interesting things about this tool. As I mentioned earlier, you could do the analysis for zones or you could do the analysis for parcels. This is the parcel data for the city of Moscow. And I could just run the tool such that it's going to create a bikeability for every parcel in the city. And that's one way to run the tool. You can also use parcel file for your destinations. Let me open up this parcel file attribute table. You see this is providing the address for every parcel and then also what the land use is for that parcel, so commercial, public, government. And then what I've done is I've provided points for each land use type. So residential, we don't think of that as a destination, that's more of an origin, so I gave that a point value of 0. For commercial land, we give it 20. For public and government institutional, 15. And this was just numbers chosen for illustration in the example file. But these point system could be given for all of the destinations for every parcel, and perhaps it's decided based on public input, some public involvement activity where restaurants get so many points and the bank gets so many points, elementary schools and public parks get different points. And depending on the land use then, the bikeability will be calculated for those to arrive at those destinations for the points that they're associated with them. I'm not going to run the tool again because of the time that it takes. Instead, I'm going to move on to the next tool. This is identify probable routes to a destination. Let me bring back in my big analysis zones and go to full extent. And we'll turn off this destination, remove it, and we'll bring in the bikeways. So here are the bikeways again. So now I'll go to this tool, the Identify Probable Routes to Destination tool. In this tool, I'll explain it as I'm running it, and all of these tools have information in the help files as well as in the ITD report for more details on how they're running and what they're doing. This tool asks for the bikeway network, it asks for the analysis zones, and then it asks for a single destination that you click on the map to get. So I'm going to click this button and then choose a destination, and I will choose here, this is the community center in Moscow. Click on that destination. It wants to know where's the output. I'll put as output community center. Save that, and then I run the tool. So what this tool is doing is it's taking from every analysis zone to the destination that I identified by clicking on the map. And it's routing on the shortest path, preferring the best bicycle suitability. So if someone were to go from every analysis zone to that destination and choosing the best route, this is the route that they would take. There's the output. It's showing with a thicker line the higher expected use coming from all of the analysis zones. And it demonstrates that there are some corridors that would get a lot of use, and in fact here this corridor here is one in Moscow that is being considered for a bicycle boulevard. And this is what the intent is for the community to see, oh well, this street would get a lot of use if people were going to this destination. So you could choose a community center or an elementary school or a high school or just a downtown as your destination, and then this would suggest where the key routes to that destination might be. And I haven't mentioned this yet, but I'll do that now, that you can always use these maps by adding the base map. We go here with ArcGIS 10 has this base maps where you can choose the aerial or the Bing maps as the background. I've already added them in earlier while one of the tools was running. I added in the imagery map. So let's just turn that on underneath. And so then you see there we've got it zoomed in. Oh, here's the intersection file. Turn that one off with the Bing map on. And there you have for a nice perhaps output that would go into a public outreach event or something. It's showing the different streets with the intersection file. So that's the last of the analysis tools. The last tool here that I'm going to show is the Summarize Suitability tool. And this tool takes as input a street file. So we'll take in we'll go ahead and take in the bikeway street file. It wants to know what is the suitability text field. We know it's the BLOS text. And then we want to know which method do we want to summarize. This one will summarize the BLOS. It wants to know where's the output going to go, so we're going to do this as a summary table. We'll call it summary table, and we'll save that. We'll run this tool, and what this tool is doing is providing, we'll go to our folder that we've called temp. Here it is. Open it up, and here's showing the bicycle level of service, the total number of miles for each level of service, and the percent of all miles that this is the number of miles under each one, and then this is the percent. So 72% are level service A, and there's 1% of the miles, which is about a mile worth of F. And that is for the bikeway network there. And that was the last of the suitability tools. Let me take a moment to go over a few of the data preparation tools. I'm going to turn that back off because it slows down my screen. Come up here and let's see. The first tool is add BLOS fields to a street file. And all this does is it's going to provide those default values. So if you have a centerline file for your city and you want to put in the fields, first you need to create all those fields, and you could do that by field by field using ArcGIS, but this is just nice and convenient. It creates all of the fields and it gives them the default names. I won't run that tool because it's just so simple. And then this is the create analysis zones. Here you enter in your network, and then it will create analysis zones that hover around that network, and it does it at the dimensions of your choice. The default is 500 feet by 500 feet, and then it asks for the output, and it'll provide the output analysis zones. And the analysis zones would look something like that. That's what we have here for, I'll zoom to that again. That's the analysis zones that were created for the Moscow Street file. Now this is the create intersection file. So this one, for example, I'll go ahead and run this one. So we stick in the bikeway network, and then we want to click on what's the output going to be. We say this is all intersections, and we run that tool. And this one is creating intersections for all of it's also adding the necessary fields, and there you have it. That's for the network. It just created an intersection file, and it's going to be blank because there's no information there, but now you can go in and, again, just for your signalized intersections, provide the necessary data. The next tool that I'll review is create street file. Now, this is a very important and useful tool. In order to explain the significance of the tool, I'm going to go to PowerPoint for a moment to discuss topology. Topology is the connections between streets at intersections. Here I'm showing an example of correct topology where the streets, which are also called links, are connected at nodes. Now this is an example of incorrect topology because the links, although it may appear that they're connected, as far as the GIS database is concerned, they're not connected because there is not a node at this intersection. Here's another example of incorrect topology where the links are not connected because they're misaligned with offset nodes. If you want to know more about topology, you can go to the ArcGIS help webpage and search in the search box topology, and one of the first returns will be topology basics. And here you can read about topology, and there are actually a number of tools provided in ArcGIS that help for editing topology and fixing topology. So if you have a centerline file for your city that you want to use, you can use the existing ArcGIS tools to fix your topology. You can also use this create street file to get a street file with correct topology. And the way this works is you enter in zip codes for any zip code in Idaho. And so let's enter in, as an example, 83301, and then we hit enter. And I actually could add a number of zip codes, several zip codes, as long as they're touching each other and contiguous. And then I have to provide where the output is, so we'll say that this is going to be 83301 zip, and then run the tool. And what this is doing is it's actually going to a shapefile which is in tool data, and it's a shapefile of all the streets of Idaho, and it's clipping out the streets that are within that zip code. It's actually a really big file there in tool data, so if you want to reduce the size of your folder and you don't feel like you're going to need this tool, you could delete that 150 megabyte file that has all of the streets in Idaho. Let me go. Here's the output. Let me zoom to that layer. So here is the streets for this zip code. Now, you're not done yet. You need to do some fixing here. These little isolated streets, which aren't connected, need to be cleaned up. And that was just a result of the way the zip code shape was, that it cut out some pieces and left some pieces. So we need to make sure that we get rid of those. And the best way to do that is to turn on the editor and say we're going to start editing this one. And let's say, for example, that our study area is just this central area here. So I'm going to go up here, I'm going to highlight this, and I'm going to say this is the area that we're studying. I'm going to open up the attribute table, and then you'll see this shows everything, but what was highlighted there, we want to switch that selection, and then we're going to delete everything else, and then we'll save our edits, stop editing, save edits, yes, and then we'll refresh that, and now it's just this little piece here. We zoom in, and it looks like there's actually a few more pieces that would need to be deleted. This piece here, so I'll start editing again, and I will highlight that piece there because it's not correctly connected to the rest of the network. Open attribute table, I'll delete those there with that delete button, and then I will stop editing and save my edits. And now it looks like we have a street file with correct topology. And the other thing is we have all of the attribute fields added to this street file. What we need to do now is fill these in. Well, what we have to help us do that is the classification of all of the streets. And so here we have locals, primary highways, and secondary highways. And if we use this tool called Enter Estimated Data, we will be able to populate those fields. And the way this works, first we need to create in Excel a table like this. And so here it's showing the class attribute, so primary highway, secondary highway, local, and alley. And then for each of the attributes that will be used to calculate bicycle level of service, we have the associated values. Now these are just estimated values and rough values, and certainly sometimes on a primary highway the width of the outside lane won't be 12 feet, it'll be something different. But I've just created this table as a starting point for the new shapefile that was created. And you could use any classification system. It doesn't have to be these four. It could be functional classification of collectors and as many categories as you want, and you can have any set of data here that you have for your community. And it needs to be saved as a CSV file. I've already saved it, so I won't save it again. And then once you have that, then we'll go to Enter Estimated Data, and it asks for the shapefile needing the data. So let's go to that new shapefile we just created, and it needs to know first what's that category field, and that's the first field in the table. It has to have the exact same name in the shapefile class. It can be any number of classifications though, but as long as it has that name, it'll match it up. And I want to know where is that example data. So here's the CSV that was created, and then I enter that in, and I hit OK, and now it's matching up for each class the data that needs to be entered. And this is just a starting point. We can then go in and go to specific streets that we know have something different happening and change the values for those streets. So now the tool is run, and we are able to look at the data that has been entered. So there it is. It's been entered for each class, and perhaps we know that this section of highway, and I'll highlight that, There's actually a bike lane there, so we want to go in and say field calculate. We're going to say there's a 5-foot bike lane in on that street, and we go in and make individual changes now once we have this starting point. So this is a good way to get started with your data, and then go in and refine it with specific changes. Well, where did all of this data come from? How did we decide how to make this CSV file? We could go out and collect data at a few functional classifications in order to get the general sense of what's happening in our community. We can use Google Earth or Google Maps to zoom in and calculate widths of things. You can estimate volumes perhaps just based on the functional classification, and then go in and provide details for specific streets that maybe we want to look at with greater detail. That was the last tool, and now I'm going to end with this contact information for Maureen Gresham. Maureen is the bicycle and pedestrian coordinator for ITD, and she can be reached through this email address. Thank you for participating.